After pre-processing, we go another step. Next one is beam measure selection steps. If we click beam measure in the model, this is a beam model manager, and in the model manager toolbar as shown below, the following dialog appears. Select the line selection and select linear, maybe 1D, and beam measure. In the line beam meshing, linear model, here set the element size to 5mm element. This is linear model. This is maybe quadratic model or another model. I will show you later. And designate the linear as the element type to designate the shape function as a linear model. Here set the element size to 5mm and click OK. For a shape with a complex shape or a shape with a lot of curvature, it is desirable to set the shape function to quadratic. This is quadratic. However, this is only linear model, therefore I will select linear model in this time. Therefore, in the beam measure toolbar, where is the beam measure toolbar? I will find out maybe. Model manager should be here, and in this case I will select black area, black arrow like this, and this is beam measure, I guess. I think, and the first one is the element type is linear type. Second one is quadratic type. This is quadratic type, and near here we can find the element type should be linear type, I think. And element size could be given to 5mm in this case, and the minimal mesh can be checked in this time. And please select this one. Then the size color of the line should be changed from white to yellow color like this. And please click OK button. Then we can find please select maybe linear analysis and linear manager, and the finite element model, node and element. If we click node and element, then 1D mesh can be generated like this. You can find the 1D mesh in this one, and next step is selection property assignment. Maybe property assignment should be needed for this step. This step is somewhat complexity. After completing the mesh work, it is time to give the section properties. In the case of one-dimensional element, it is defined through attribute information rather than directly modeling the cross-sectional shape. In other words, in the case of generalized shapes such as I-beam or rectangular section, it is much more accurate and convenient than analyzing with actual modeling. And first, execute the 1D property command from the model manager toolbar. This is 1D property model manager toolbar, and here select the line element input as edge and select the rectangular beam as shown in the following figure. for the section type. Also click on the component edition and enter the horizontal and vertical sections as 5 millimeter. 5 millimeter. Therefore, I will show you in CATIA program once again. And in this case, the next step is to select 1D property. Maybe this is the shape is like I-beam shape. And in this time, if you click 1D property, then you can find out the 1D property dialog box. And in this case, support should be maybe support should be selected. In this case, one edge should be selected for support. One edge should be selected in the line like this first, and the second one is to select the type rectangular beam, cylindrical beam, or you can find out if the cylindrical beam, then this is like cylinder, and tubular beam is similar, thin boxed wall. In this case, we should select rectangular beam, I think. Rectangular beam is placed in this part, and we can select the rectangular beam. And in this case, please click this button. If you click this button, then beam definition dialog box should be appeared like this, and length X should be, Y should be 5 millimeter, and length Z should be 5 millimeter once again. This is 5 and 5. If you define this is 50 millimeter, then the box should be enlarged like this. This is the beam section definition menu. Therefore, in this case, following as the document sheet, lecture document sheet, we should define it as 5. In case of length, Y should be given to 5 millimeter, and the length Z should be given to 5 millimeter once again. Then if you click OK, then that is activated, and in this case you can select well, and next step is to select material is steel material, rectangular beam, and orientation geometry should be selected to orientation geometry. In this case, orientation geometry should be selected maybe I guess this is orientation. I guess this is orientation. In this case, we can magnify it X and Z direction is the orientation, and if we click OK, then this property can be shown. X and Z axis direction should be generated in this operation. Well, Shortly I will show you the beam bending stress in beam. That is needed to know. We should have knowledge about bending stress in beam analysis. When a bending moment is applied to the beam, as shown in the following figure, some tension and compression. This is compression direction, and tension direction is like here. The AC side receives tension, and BD equal receive compressive stress, therefore resulting in bending stress. However, there is no change in the neural plane, and the stress increase in proportion to the distance y. Y distance is very important from the plane. And also some section coefficient z is differentiated in like this, following as the profile shape. This is rectangle shape, this is I-beam shape, and this is the circle shape, and this is tubular shape. In this case, the z coefficient is differentiate each other. That is specifically explained in the material mechanics or solid mechanics subject. If you see solid subject theory or solid subject books, you can find out about this bending stress theory like this. However, we should know why does bending stress sigma c equal m over z. M is the bending moment, and z is the coefficient, profile coefficient, and z is differentiated dependent on the section section shape. Like in case of rectangle type, the z coefficient should be bh square per 6. This is b and this is h in the beam, and this is somewhat different. And in this case, if there is a solid tube, solid pipe, then the z value should be pi d square per 32, and if there is tubular, then the z value should be pi over 32, and d2 4 scale minus d1 4 scale slash d8. This is d1. This d1 is the inner tube diameter, and d2 should be outer tube diameter, and t is the thickness. And this is d3. I'm sorry, my d1, d2, maybe this is d2 also. Yeah, d2. I'm sorry, this is different. That is d2 also, and d2 is the outer diameter. Therefore, following as this beam theory, we can give to the boundary conditions for restraint in the beam analysis problem. For beam deflection analysis, it is necessary to fix one end, activate the restraint and load toolbars shown in the following figure. If we select the clamp from the restraint toolbar, a dialog box appears. Select the one point edge. This is point shown in the figure before the click and below, and click the OK button in the dialog box window, and then the clamp is fixed with 6 degrees of freedom. 6 degrees of freedom is there are six. One is first one is x, second one is y, third one is z direction, and maybe first one is x theta. X theta is rotation in the x along to the x axis, and maybe in this case also maybe x theta should be changed to the subscript like here. Therefore I will copy this one and change it to the subscript. Y theta should be the rotation along y direction. Maybe this is y direction. Maybe y theta is rotation like this, and x theta is rotation like z theta is rotation along to the z axis like this. Here the degree of freedom indicated by the subscript indicate rotation in that direction. Therefore next one, we should click clamp in the restraint toolbar, and please in case of clamp 1 we should select the list point should be here. If you click this one, then the one point should be selected like this. Like this, and this one vertex like here, and please click OK in this case. Oh, I'm sorry, this is unnecessary point can be selected. Therefore I will click once again. Please click restraint button, and please click this one, only this one, and the next time we should select next time for applying loads in boundary conditions. A load can be applied to a surface, edge, or point of a shape. Click the distributed force button on the toolbar. Note the direction of the load. In this example, a load of 200 Newton is applied in the z direction. After selecting the 2 points shown in the figure below, input the load value of 200 and click the OK button like here. Maybe in this case, in CATIA analysis, there is no separate concentrated load selection, therefore manifold load conditions. So if a distributed load value is assigned to a point, a concentrated load is applied. That is some note in CATIA program. Therefore, please click this button is the place in distributed force, place in loads toolbar, and support should be selected to this one. In this point we should give them a load, and in the minus 200 Newton could be applied in the z direction like this. and then please click OK in this time. Okay, if that is finished, the next step should be needed. And another next step is check the FE model to check whether the basic items are defined or not. Activate the model manager toolbar as follows. If we click the model checker traffic light like this, the button, you can see that OK is displayed. Status, if status OK, then everything is completed. After confirmation, click the OK button in the dialog box. Therefore, for finding out everything is OK or not, we should click the light color, light traffic light, and if the status OK, then please click OK button in this time. I've confirmed that is OK then. And that is last step. Solving is needed for last step. First one, command to find the solution by calculation. Let's look at the process of finding a solution to the FE model defined above. Activate the compute toolbar as shown in the following figure and click the button. Selecting the OK button in the dialog box means that you want to calculate everything. You can select a map to calculate only a specific solution case. As shown in the following figure, if the resource required for calculation is displayed in the dialog box, click the Yes button and the calculation starts at this time. After computation status is displayed and the calculation is completed. Also, here you can see that the window appears after the calculation is displayed for a while. If an error occurs during calculation, it means that there is a part missing in the given condition, or there is a part set incorrectly. So you have to go back to the modeling window and make corrections. It is possible to check the storage location of calculation results and the post-processing results in the tree as shown in the figure below. Next step, we should click a calculation button. We can find out the calculation button maybe here. This is a design table. We should find the calculation here. Computer button, and please click computer button in this time, and if you click OK, then some warning is entry clamp 1, no mesh element located to support point 1, and compute estimation that occur error. CPU estimation not available. Error can be occurred. Clamp 1 have some problem in this case, therefore we should check it. Clamp 1 also again. Okay, this part have some error. If error is occurred, then we should check the clamp is well managed or not. Clamp 1. remove a support, and in this time we should check the clamp. Clamp 1 should be one vertex, selected one vertex in this menu. Okay, I will, the time is ended in this step, therefore I will show you and continuously have a lecture with you in next time. Thank you for watching in this time, and I will come back again. Thank you.